Hello everyone, welcome to this episode. This video is brought to you by the Maritime Craftsman Society and is my 12th installment as a craftsman. This series shares my personal insights on using BC Sum during my research. It helps offshore engineering PhDs understand the software to contribute to marine industries. This series excludes cracked software, internal materials, or paid tutorials. It is for non-commercial academic exchange only. This is not official training and is unrelated to BAS position. Today, I will explain a relatively simple structural analysis process. Generally speaking, aside from memory analysis, our structural analysis always involves certain steps. Before conducting structural analysis, you need to perform either frequency domain or time domain analysis. If you are doing frequency domain analysis, after running Systra, you will obtain the structural response of this structure in the frequency domain. If it is time domain analysis, after running Sichuan, you will obtain the predicted behavior of this structure in the time domain. For structural analysis, a necessary model is the T3 model. This is what we refer to as the structural model. After the analysis is complete, if there are no errors during the analysis, you will get an R3 file, which can be opened with extra. Alright, next I will walk you through the operation. For example, let's say I have a box here. I will use this box to simulate an auxiliary structure. You can also see that there are some stiffeners on the plate of this box, which are made of flat steel. Next, I will group all these stiffeners together. I will define them as a set. This is to make it more convenient when viewing the post-processing results later. It will be easier to select them. Now, in the mesh settings, change the Superman type to 3 because we are outputting the third model. For the next step, we need to add a boundary condition. At the bottom edge, click on Support and select the 4 points at the bottom. Set all the types to Fixed, meaning they are fixed supports. Of course, you can also enable other degrees of freedom. This depends on the specific problem and analysis. For now, we will set them all to Fixed. There are 4 points in total. Okay, now our boundary conditions are set. Because this is a special type called Systra, you must set these boundary conditions, otherwise Systra will give an error when running. Next, let's run this mesh. Once the mesh has finished running, we move on to Hydro D. In Hydro D, we create a new Hydro model. Import a T1 file. Then, we take the structure model we just created and bring in the structure model as well. Alright, let's create a loading condition. I'm going through this part quickly because the basics of the frequency analysis were already covered earlier. Now let's create a new location, C star Julia. Then, set a wave period. Okay, let's create a new location. Then, set up a condition for the frequency analysis. As you can see, I'm not following the built-in wizard for these steps right now. Once you're familiar with it, you don't need to rely on the wizard anymore. Alright, now let's create a new max model. Just enter any mass value. Next, let's input a Morrison model. For this Morrison model, I've also just prepared a random T2 model. Here I'm using Tishan, but that's fine. Sometimes, if the Morrison element isn't simulated, it might throw an error. Here is where you define your effective diameter and the Tuyeri coefficient. Of course, you can just enter any diameter here, it doesn't matter. The two numbers below are your Tuyeri coefficients. This set is the one I previously defined in Gene. Alright, let's click OK. Next, let's create a new Wadamura. Then we need to select the structural model here. And we need to click Load Transfer. Loader transfer means you need to calculate your structure again. Just enter anything here. For the push speed, just give any value. Enter 2, that's fine, click OK. Then let's run it. Alright, the run is finished. Here, we just right-click on the main one and perform the structural calculation. After the structural calculation, you can see that an R3 file has been generated here. In your Haloader working condition folder, there is now an extra R3 file. Let's left-click and double-click this R3. At this point, your Xtrang will open. Let's left-click and double-click here. What you see now is the result of our evaluation analysis. We can click the lower left corner. Let's take a look at the element. Let's check its distress. That is, the principal stress. Below that, there are also piece stress and distress. Let's take a look, as Yibang said. Honey Saisiingli. Alright, this is the stress contour map in the frequency domain. Click here to view its deformation. As you can see, the plate below here is bent inward. The deformation is still quite obvious. For example, if I want to check the stress at a specific element or node now, and plot it on a single graph, we can just click Graph. Click the first option. Then we click on Occurrence. Select the point you want to view. Then choose an empty box. Performance, Create. Now we've obtained this result, which is for your selected point. Under this working condition, the stress curve. For balance, we can select some other results to view. If you want to export a view from this software, for example, with the structure on the left and the graph on the right, we can click the camera icon here. Click the first option. In this way, the white background will be copied to your clipboard. We can just right-click on a blank area. That was the one I just exported and pasted with right-click. Okay, so we've exported a screenshot. Clicking Show Graph again will remove this image. Alright, now let's take a look at the color of the contour plot. If you want to change the color of the contour plot, you can do so in the result settings. Click on Minimum and Maximum. Let's adjust its range. If the range is changed, the corresponding colors will also change. You can see that the colors have become much more distinct, right? Maybe the range I adjusted is a bit too large. Alright, if you want to export the stress of a specific node or element, you can click on List Result. Here, it shows different ones. Different mesh elements, we can see the different mesh numbers, and on the right, there are 4 corresponding values. Why are there 4 values? Because the current option is element, and each element has 4 nodes. The value for each node will be displayed here. Alright, let's click Reload. For example, I select a node and then click Save. Then it can be saved as a document. Next, another commonly used function is scanning. Scanning means, in the upper left corner, we click here. It can include all your working conditions. First, select all these working conditions and move them to the right. Then, the object you are scanning is the maximum value. Alright, here we need to give it a name first. This means that among all your working conditions, I select each one. Select the maximum value for each element or each node. The maximum value of the stress. The error just now meant that it didn't know which result to scan, so we need to click first. For example, I click on 1. Let it scan under this distress. Let's just change it to distress. Alright, let's click Update. After clicking, we can see one here on the left. I just entered one. The U here is the maximum value that was scanned. That is, the maximum von Mises stress value on each mesh under all your working conditions. Of course, the minimum value is obtained in the same way. Alright, that's the end of today's sharing. Thank you.